this video, I'm going to talk about adding and subtracting rational expressions. Rational expressions are just fractions that have variables in them. They're fractions with variables. And the key word is fractions. So when I'm adding and subtracting fractions, I need to make sure the two fractions have the same denominator before I can bring them together, or before I can subtract them. So I want to do a fraction flashback to just two fractions with just numbers in them, no variables. When I have this situation, 2/3 plus 3/5, I need to make the denominators the same before I can add these two things together. So I need the same denominator. I want to change these two denominators to be the same, and I can do that by multiplying by the same thing on the top and bottom, keeping these fractions balanced, but changing their denominators. And I want to know, first and foremost, what do I want to change those denominators to be? So what I want to change those denominators to be is the least common multiple, the smallest number between the numbers that I have, 3 and 5. So I need to find the smallest number that both of them fit into. The least common denominator. And we use LCD, the acronym, to talk about it. So we need to find the LCD, the least common multiples between 3 and 5. That is 15. The least common multiple between 3 and 5 is 15. That's the smallest number that both 3 and 5 fit into. So I'm going to change the denominators to be that. If I have 2/3, to change the denominator to 15, I'd need to multiply 3 in the bottom times 5, which means I have to multiply the top by that as well. I'm multiplying by a giant 1 because I don't want to change the worth of that fraction. I just want to change what the denominator is so I can add them together. For 3/5, to change that one to have the right denominator, I need to multiply the bottom by 3, which means I have to multiply the top by 3. So I'm multiplying again by a giant 1. I'm not changing the worth of that fraction, or I'm not changing the ratio. I'm just changing the denominator. And when I multiply by 1, the thing that I multiply 1 by stays the same. For the left fraction, I'm going to have 10 over 15. For the right fraction, I'm going to have 9 over 15. When I add these together, I have 19 over 15. This is my answer. I want to do the same exact thing when I have rational expressions with variables. So for number 1, I have x over 3 plus 2x over 6. If I want to add those two things together, the first thing that I'm going to do when I'm adding rational expressions is I want to find the LCD. So I'm going to write the LCD off to the side somewhere. The least common denominator between 3 and 6, or the least common multiple between 3 and 6 is 6. 3 actually fits into 6. So I don't need to even change the second fraction. I just need to change the first one. The least common denominator is 6. So I need to change x over 3. I need to change the denominator to be 6, so I need to multiply by 2. And I need to do that in the top and the bottom. I'm multiplying by a giant 1, not changing the worth of that fraction. Plus, I have 2x over 6 that I don't need to change. When I fix the left-hand fraction, I have 2x over 6. 2x over 6 plus 2x over 6 is going to give me 4x over 6. I can simplify this a little bit. 4 and 6 have a factor in common of 2. I can divide 4 by 2 to get 2, and 6 by 2 to get 3. And my final answer is 2x over 3. And that's my answer. And then I want to talk about what my restrictions are. Oh, there are no restrictions because there's no variables in the denominator, so no restrictions. For 2, I have 3 over x plus 4 minus 2 over x minus 1. So I saw that 3 and 6 shared something in common. I saw that 3 fit into 6. X plus 4 doesn't fit into x minus 1, and x minus 1 doesn't fit into x plus 4. And neither did 3 or 5. 3 and 5 didn't share anything in common here. So what I did to find the least common denominator is I multiplied the two together. I multiplied 3 and 5 together to get that LCD. And sometimes that's what you're going to have to do. The least common multiple is going to be multiplying those two things together. And in this case, that's what it's going to be. So the least common denominator is going to actually be x plus 4 times x minus 1. That's the least common denominator, and then if you simplify that, that's going to be x squared plus 3x minus 4. And so I want to change the denominators to be x squared plus 3x minus 4. And I have to change both of these fractions. So I have 3 over x plus 4. What I'm going to need to multiply that denominator by to get this least common denominator is x minus 1. So I'm going to multiply the bottom by x minus 1. And if I do that in the bottom, I have to do that in the top. For the second fraction, to get x squared plus 3x minus 4 in the denominator, I need to multiply the denominator by x plus 4. And if I do that in the bottom, I have to do that in the top. The left fraction is going to become 3x minus 3 all over x plus 4 times x minus 1. I'm going to leave the bottom in factored form before the end so I can see if there's anything that I'm going to be able to cancel. And then for the second fraction, I have 2x plus 8 all over x plus 4 times x minus 1. I can rewrite, I know the bottom of my fraction when I combine these is going to be x plus 4 times x minus 1. The top is going to be 3x minus 3. And then I'm subtracting 2x and I'm subtracting 8. So minus 2x minus 8. Make sure when you have subtraction, you distribute that negative. And then when I collect my like terms in the numerator, I have 3x minus 2x is x, and negative 3 minus 8 is negative 11. And so now I know that that doesn't have anything in common with what I have in the bottom. So I'm just going to simplify to this, x squared plus 3x minus 4 in the bottom. This is my fraction, my simplified answer. Because there's variables in the denominator here, I need to talk about my restrictions, what x cannot be equal to. The only things that I had in the denominator were x plus 4 and x minus 1. So x cannot be equal to negative 4 because that would make this 0, and x cannot be equal to 1 because that would make this 0, and I'm not allowed to have 0 in the denominator. For number 3, I have 7 over x minus y minus 2 over y minus x. Now, it may look like you have to multiply these two things together, and you can do that, certainly, and then you're going to have to simplify at the end. But what you should be able to notice is that these things actually, one of these things can fit into the other, or I can rewrite one in terms of the other. What I have here is a positive x and a negative y. Here I have a positive y and a negative x. To go from here to here, I would need to multiply by negative 1. Or what I really want to do is I want to take y minus x, and if I multiply that by negative 1, I get x minus y. So I can say that the least common denominator is actually x minus y. And then I don't have to change the first fraction, I just have to change the second fraction. I have 7 over x minus y minus 2 over y minus x, and all I have to do to this fraction to change it, to that denominator, to change it to x minus y, is I need to multiply by negative 1. And if I do that in the bottom, I have to do that in the top. And so I'll end up with 7 over x minus y minus, and this is negative 2 over, I'll have negative y and positive x, or x, I'll write it out. I'll have, this is equal to negative y plus x, which is the same as x minus y. So this denominator is x minus y. And I get 7 minus negative 2, or 7 plus 2 over x minus y, which is 9 over x minus y. And this is my answer because I can't simplify that any further. And then I say x, I have to say what my restrictions are. My restriction is that in either of these cases, I can't have x and y equal to each other. So x cannot be equal to y. You can also write y cannot be equal to x, but those are the same statement. So you only have to write one of those two things. For 4, I have x plus 1 over x squared plus 5x plus 6 plus 4 over x plus 2. The first thing I'm looking for is the LCD. And what I want to check is to see if one of the denominators fit into the other. That's what I want to check first, so I can see if I can save myself some time so I don't have to rewrite both fractions. And x plus 2 does actually fit into x squared plus 5x plus 6. It actually is a factor. If I multiply x plus 2 times x plus 3, I'm going to get x squared plus 5x plus 6. So my least common denominator is x squared plus 5x plus 6. This is a factor. So I only have to rewrite the second fraction. I can leave the first one the same. X squared plus 5x plus 6 plus 4 over x plus 2. To change this denominator for the second fraction to be x squared plus 5x plus 6, I need to multiply by x plus 3. So I'm going to multiply by x plus 3. If I do that on the bottom, I do that in the top. I get, this is going to become 4x plus 12 all over x plus 2 times x plus 3. And I'm adding that to x plus 1 over x squared plus 5x plus 6. And I'm going to rewrite this as x plus 2 times x plus 3. And then I'm going to combine these. I have 5x and 13. That doesn't share. There's nothing I can simplify. There's nothing I'm going to be able to cancel x plus 2 or x plus 3 with, so I'm just going to FOIL, and I'll have x squared. I have x squared plus 5x plus 6 in the denominator. This is my final answer. And then I just need to say what x cannot be equal to at the things that I had in the denominator were x plus 2 and x plus 3. So x cannot be equal to negative 2 because that would make this 0, and it can't be negative 3 because that would make this 0. Those are my restrictions. And then for 5, these two, neither of these fit into each other. I don't have opposites that I can multiply by negative 1 to get the other. I have to multiply these two things together to get the least common denominator. So I have to multiply a plus 2 times a minus 2, and I get a squared minus 4. It's the difference of two squares. And so I need to change both fractions. The first one, I need to multiply by a minus 2 in the denominator to change it to x squared minus 4, so I have to do that in the top as well. For the second fraction, I need to multiply that denominator by a plus 2 to get a squared minus 4. I need to do that in the numerator as well. So I'll end up with 3a minus 6 all over a plus 2 times a minus 2 plus 4a plus 8 all over a plus 2 times a minus 2. And when I combine these, I have 3a plus 4a gives me 7a, and I have negative 6 plus 8 gives me plus 2. 7a plus 2, I can't factor that to have anything in common with what I have in the denominator, so I'm just going to simplify the denominator to be a squared minus 4. This is my final answer, and then my restrictions are what x cannot be equal to, and the only thing I had in the denominator was a plus 2 and a minus 2, so from x cannot, a cannot be equal to negative 2 from here and positive 2 from here, because those two values would make the denominator 0. For number 6, I have x plus 3 over x squared minus 4 minus 3 over x plus 2. I want to do these two things. Does one fit into the other? Because that's going to help me save time. And yes, x plus 2 fits into x squared minus 4. X plus 2 is a factor of x squared minus 4. If I take x plus 2 and I multiply it by x minus 2, that gets me x squared minus 4. So my least common denominator is x squared minus 4. And so I only need to change the second fraction. I leave the first one the same, and I change the second fraction. I multiply that denominator by x minus 2 to get x squared minus 4. So I do that in the top as well. I have x plus 3 over x squared minus 4 minus, this is 3x minus 6 all over x squared minus 4. And then I should have really left the bottom as x plus 2 times x minus 2, but I'm going to keep in mind that that's what's in my fraction if I see anything similar in the numerator when I simplify. And I'm going to rewrite this. I know the denominator is x squared minus 4, In the numerator, I have x plus 3 minus 3x minus negative 6, which is plus 6. And that gives me negative 2x plus 9 all over x squared minus 4. Negative 2x plus 9 does not share anything in common with x plus 2 or x minus 2. So I can leave the bottom as x squared minus 4, and I don't have to simplify any further. And then my restrictions are, the only thing that I saw in the denominator was x plus 2 and x minus 2. So x cannot be equal to negative 2 or positive 2. And then for the last one, I have 3 fractions. Nothing changes. I still need to look for the least common denominator. I want to see, does one fit into the other, or do 2 fit into the other? I know x plus 2 fits into x squared minus 4. And this one's weird. Does that one fit into x squared minus 4 as well? Well, it doesn't look like it, but if we look at the other examples that we did, I had x minus y and y minus x were opposites of each other. So here, in this example, 2 minus x is actually the opposite of x minus 2, a positive x and a negative 2. So if I multiplied 2 minus x by negative 1, I would get x minus 2, which is a factor of x squared minus 4. So x minus 2 x plus 2 is my LCD, which is x squared minus 4, because these two do fit into this one. And I only need to change the first 2 fractions. So I have 5 over x plus 2. I'm going to need to multiply that denominator by x minus 2, which means I have to do that in the top as well. For the second fraction, I need to multiply by 2 things. I need to multiply by negative 1 first to flip, or to change this to its opposite. It's going to be x minus 2 after I multiply by negative 1. And then I also need to multiply by the other factor of x plus 2. So x plus 2 in the top and at bottom. And then my last fraction stays the same. It doesn't change. And now I'm going to rewrite the fractions that I have. So the first one is going to become, when I distribute that 5, it's going to become 5x minus 10 all over, I'm just going to write it x squared minus 4, plus I'm going to have, this is negative 5 times x plus 2. So this is going to be negative 5 times x plus 2. So negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. All over x squared minus 4 minus 6 over x squared minus 4. I'm going to collect all of this. So I have 5x minus 10 minus 5x minus 10 minus 6 all over x squared minus 4. The 5x's cancel each other out. Negative 10 plus negative 10 is negative 20. Negative 20 minus 6 is negative 26. That's negative 26 over x squared minus 4. The top and bottom don't share anything in common, so I can leave this as my answer. This is the simplest form. And x, the only thing in the denominator was x minus 2 and x plus 2, so x cannot be equal to 2 or negative 2, again. And that's rational expressions, adding and subtracting.